have one more quick video here just to try to reiterate some of these concepts because it is really confusing. It's a lot to keep straight. In this unit, there's lots of formulas we're going to be learning and lots of information that looks like it's conflicting, but we just have to keep the differences between them straight. So we talked about, to start off with, we had some pictures like this where we have our center of our circle here and lots of lines coming off. We're going to be finding the arcs and the angles. Pay attention to which one they're asking for. So before we even talk about this picture really, or what we're trying to find, let's look at what we have. Now, I know this is a little right angle right here. That's given to me. A right angle has how many degrees? 90. So this is given to me as 90 degrees. That's guaranteed. Now, what this question is asking for is what is the measure of angle BAD? So I'm going to highlight that. All that I have is that this is 90 right here. That's the only piece of information I have. Except there is something in this picture that we always have to keep an eye out for, and it is the fact that this line is called a what? That's a diameter. That is a diameter there, and a diameter cuts a circle in half. It creates a semicircle, yeah? So if I know that this is 90 and all of this is a semicircle, let's have a little refresher here. How much would all of this be since it's a semicircle? How many degrees? That's 180. The whole thing is 180. That's half of the circle. That's half of a turn. If you do a half turn, you're turning 180 degrees. So therefore, if this is 90 here and this whole thing is 180, what is this red angle I highlighted? What does it have to be? 90 as well. That's actually two right angles bumped up against each other. Now again, that's this whole angle. That includes this piece over here as well. It's not just this angle, it's all of this. So all of this is 90. So keep in mind, sometimes you're not going to be given a lot of information. You have to use the info that's there. If there are any angles marked, you have to see in your head, oh, that's a diameter. This whole thing is 180 degrees. I'll use that. You have to really keep that in mind. So going from here, is angle BAD, which is the one we just found, is angle BAD a central angle coming from the center of the circle, or is it an inscribed angle, which starts, its vertex starts on the circle? What do we think? This is a central angle because A is the center of the circle, right? A is right there in the middle. So that makes this a central angle. So once again, this angle we just found, we would call a central angle. Now, because of that, because it's a central angle, it's going to be very easy for us to find the measure of this arc. Because we know that if I have this central angle, what's true about the corresponding arc, we say? Notice this angle opens up to BD. These two are going to be the same when it's a central angle only. Central, same as the arc. So if the angle is 90 here, what does the measure of this arc have to be? 90 as well. Oops. That is only because the angle comes from the center. Again, that relationship does not apply if the angle does not come from the center. But because it does, the angle and the arc are going to have the same measure. So, repeat after me. I solemnly swear to keep an eye out for semicircles, because again, we might not be given much information, but if we see that we have a diameter cutting that circle into half into 180 degrees, that does give us some information. And that can help you a lot when solving these problems. Sometimes you have to know that in order to do the problem. For example, here, we need to know this whole thing was 180 degrees to figure out, well, if this is 90, that has to be 90 as well. So you promise to look out for diameters when we're dealing with central angles. Let's do another example here. So now, so a bit, there we go. Angle CAD and angle CED. So pause yourself, guys. Sometimes I know we just read and we're like, my brain just kind of goes. But we have angle, pause yourself and highlight them. CAD and angle CED. Notice they open up, they cut my circle into the same arcs. What arc do they both open up to? They both open up to arc CD. Notice again, my angle opens up to CD. My smaller angle coming from the back there also opens up to CD. They open up to the same arc. Major, shush, what are you worrying about? Okay. Now, again, what we have to remember here, though, is that these are different angles. There's different relationships going on here between the angles and our arcs. Angle CAD is what type of angle? A central angle. That's coming from the middle of the circle, the center, right? Whereas angle CED, what type of angle is that? Because it starts here on the circle. That's an inscribed angle. Remember, inscribed, the vertex, the corner of it, starts on the circle versus starting at the center. So let's say that we knew that angle CAD was 60. Label on your picture, where is angle CAD, and put a 60 there. Well, that's going to be right here. This is CAD, it's 60. So we can use this fact to find what the measure of arc CD is. We know coming from the center here, this angle has a special relationship with the arc. What is the arc going to be here because this is a central angle? It's going to be the same. Because it's the center, this arc is going to be 60 degrees. So the measure of arc CD is 60. Center, same. Now, though, we want to find the measure of angle CED. So once again, trace CED. I want to know what this is. Now, this is a different relationship because, again, this is now an inscribed angle. Now, it opens up to 60, but this angle is not going to equal 60. Again, it opens up to the big arc, and then it comes down to a little point. So think, based on the relationship we know here, I have the big arc coming down to a smaller angle. What should my angle have to be? Well, we know that with inscribed angles, they are half of their arcs. So this angle needs to be half of 60. Again, think the arc is big, and then we have that little angle right there, so you can tell when you should be taking half or when you should be doubling something. We have the small angle and we're opening up to the big arc. That's a double relationship. If I have the big arc and I'm coming down to a small angle, we are halving it. So once more, you solemnly swear to make a mental note or just write it down. What an angle is a central angle, or inscribed, as that is very important to my answers. Central angle, same as the arc. Inscribed, either half or double. We got to be careful with which direction we are going. So I hope this helps a little bit more, just one more time, kind of going through these concepts so that you can do okay on your assignment.